Okay, so we're going to spend the next couple of weeks working on multiplying polynomials. Then we're going to take a break. I think we're going to do some plane geometry. Then we're going to go to factoring. So factoring is the opposite of multiplying. So let's take as an example this expression. So the way Kant teaches it, he likes to take x minus 3 and distribute it here, here, and here. It's distributed to both the x minus x plus two, x and the plus 2. So here's my x, here's my plus 2. Then you distribute again. It's kind of a double distributed property. And so now I need to distribute the x to both the x and minus 3, and that gives me x squared minus 3x. Then I distribute the 2 to the x and minus 3, I get 2x minus 6. Then you can combine like terms. The minus 3x and plus 2x is minus x, and you get x squared minus 6. So that's what we're doing this week. We're multiplying them. Well, then in about 3 weeks, we'll start factoring. And the way you factor is you start with that minus sign. This is where we wound up when we multiplied. Now we're going to start with that. So we got x squared minus x minus 6. Well, this minus sign tells me it's going to factor to two binomials with a plus and minus. The fact that this is x squared means my leading terms in the binomials is going to be x. So I got x plus and x minus. Then it's a matter of figuring out the factors of 6. 6 could be 6 times 1, or it could be 3 times 2. You want the factors that will subtract, because that's a minus sign, to negative 1. And that would be 3 and 2. So I have 3 and 2 over here. 3 times 2 is 6. And if I arrange it right, where I have 2 minus 3, I get a negative 1. So that means I need to have the 3 be the negative, which means that I have to put the 3 in front of the minus sign and the 2 in front of the plus sign. And now it's factored. So you factor is undoing the multiplying. What we're doing this week is we're doing the multiplying. And then once you factor it, you can then solve for x. And so that's why we do all this, is so that we can solve for x. Often you can express quadratic functions, some real-world activity, as a quadratic function, and you need to factor it in order to solve the problem. Okay, so what do you think?